Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabil bin Sabar Abdullah. My supervisor name is TS Dr. Muhammad Sabri bin Hassan and my co-supervisor name is Dr. Nurul Syahira binti Khalid. My title project is Carbon Monoxide Real-Time Monitoring System Integrated with IoT. Carbon monoxide is a deadly, colorless, odorless and poisonous gas. Any fuel burning source has the potential to produce carbon monoxide from the incomplete burning fuel. In urban areas, 90% of the carbon monoxide in the air came from motor vehicle emissions. This dangerous gas displaces oxygen in the air and in our blood, thereby depriving our heart, brain, and other vital organs of oxygen. Problem statement of this project. First, by taking a nap inside the car, resulting in death due to carbon monoxide poisoning, which is caused by internal combustion engine. Second, traffic accident growing every year caused by carbon monoxide intoxication, which is seriously affect driving performance. And the third, excessive amount of carbon monoxide being released when vehicle exhaust system fail, which high risk to include young children, the adult, and people with lung and heart disease. The main objective of this project, first, to simulate coding into microcontroller based on the carbon monoxide level. Second, to develop circuit and assemble the hardware of IoT system with the carbon monoxide real-time monitoring system. And the third, to evaluate data of the accumulation of carbon monoxide in the cars. This figure shows the flowchart of the project. The program flow of the system. The sensor will read the carbon monoxide and send to the microcontroller to calculate into ppm and display on the LCD and application. After the carbon monoxide level more increasing, it triggers the threshold set as the flowchart. It will cause a certain output such as sound and alarm, turn on LED, vibrate vehicle seat, roll down car window, and send a warning through the mobile application. The program flow of the Python program. The data collected by the sensor is sending to the Blink cloud via Wi-Fi connection through the non-MCU ESP8266. The Python will be used to analyze and will be presented based on the data required and saved in CSV type file. Version of the prototype. It uses a MQ9 as the gas sensor input and the non-MCU ESP8266 as a microcontroller to control the output, and Blink application as IoT application. And the output of the prototype will be the buzzer, LCD module, red LED, vibration motor, and servo motor. Schematic connection diagram. This figure shows the schematic diagram of the connection between input and output component and hardware to the microcontroller not MCU ESP8266. Hardware and software development. Arduino IDE is to create code and transmit it into the non-MCU ESP8266. Blink application is to display and store data into cloud in the mobile application. And the prototype assemble hardware and finishing through the schematic diagram. Data collection in this project use two types of car to collect data, which is Proton Saga second and third generation. The connection when collect data is the car at the open parking going for different situation. First in the car open window, second in the car closed window, third in car while air conditioner is on with closed window, and the fourth smoke produced from fuel combustion of car exhaust. For the result output prototype hardware, when the value of ppm below than 25, LCD display normal. When the value of ppm between 25 to 200, the LCD display moderate and the output buzzer triggered. When the value of ppm above 200, LCD display dangerous and output red LED buzzer, servo motor and vibration motor also triggered. This shows the graph and data analysis of the carbon monoxide accumulated in car with upward window generated by Python. This shows the graph and data analysis of the carbon monoxide accumulated in the car with closed window generated by the Python. This shows the graph and data analysis of the carbon monoxide accumulated in car while air conditioner is on with closed window. This shows the graph and data analysis of the carbon monoxide accumulated in the smoke produced from fuel combustion of car exhaust. Based on the Python analysis, the highest value for carbon monoxide accumulated was estimated. In terms of long-term evaluation for driver to operate the car is new car is safe from carbon monoxide poisoning. To ensure the safety of elderly automobile, because poorly maintained or faulty engine can cause exhaust leak. This project highly efficient in overcoming this dangerous scenario as well as reducing the number of people who die as a result of carbon monoxide. Novelty and inventiveness. Carbon monoxide data monitoring system integrated with IoT is innovative and safety feature for the car. The system can constantly monitor the carbon monoxide level and transmit the data to the cloud-based platform. IoT integration enables the data collection and analysis over time, providing insight into the driving habits, routes, and environmental factors. The system can prevent carbon monoxide poisoning, a serious health risk for driver and passenger, especially in older car or poorly ventilated space. Advantages of this project: it can give early warning system, remote monitoring, automation, cost effectiveness, and data collection to analyze over time. In terms of commercialization, first, it can increase demand for car safety. It has a regulatory requirement, technological advancement, and potential for recurring revenue. In conclusion, the study begins with a literature review which includes learning and relevant journal thesis and online website. The system controlled by NoMCU SP8268 enable application monitoring through the phone and record data of reading concentration of carbon monoxide. The level of carbon monoxide accumulated in second generation Saga is proven to be higher than the level of carbon monoxide accumulated in third generation Saga. And all the objectives in this project have been achieved, and it has been shown that the carbon monoxide data monitoring system in connection with Blink application can collect data from the car. The simulation of debugging and transfer data coding into microcontroller non-MCU ESP8266. This shows the blink application and send warning notification in blink application in real time. This shows the turbo monoxide multi-system prototype. This shows the demonstration of a setup prototype in the car. First situation in a car with open window. Second situation in a car with closed window. Third situation in a car while air conditioner is on with closed window. And the fourth is the situation is smoke produced from fuel combustion of the car exhaust.